Okay, let's look at question 4. A second train, train B, travels north from origin station. At time t, the velocity of train B is given by the velocity of blah blah blah. And at time 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the station between train A and train B is changing at time t equals 2. Okay, so what do we have to do here? Well, I think a picture might help. So it says the second train, train B, at time equals 2. And it's going north, and at time equals 2, it is at 400 meters. Then, and it says the equation is going to be negative 5t squared plus 60t plus 25 is how we calculate the velocity of it. Okay. Then from the first part, it talks about train A, and it says train A goes 300 meters east at time 2. So we know that also that this is, we'll do it I guess in a different color, 300 east at t equals 2. And the question is how far apart are they? So how far apart are they? Well, if this is 400 and this is 300, then this has to be 500 via the Pythagorean theorem, right? We can also recall when we did these questions back in related rates that if I call this, I guess I'll call this B, I'll call this A, I'll call this C, then we can say A squared plus B squared equals C squared. And if I take the derivative via implicit differentiation, we get dA dt plus 2b dB dt is going to equal to C dC dt. Okay? What does this tell me? Well, A is the distance up that we go. Well, we said it's 400, so I can now say, let me squeeze this over here, 2 times, what did I say, 400 or 300? I said 400. 2 times 400, because A is the distance, 400. dA dt is a fancy way of saying the velocity. So what is the velocity at 2? Well, the velocity is going to be this equation right here, this one right here, right? So we just have to plug in there. So it becomes negative 5. Well, let's do this. Let me do it on a separate page here. Okay, so we'll plug in 2 here, so it goes negative 5, 2 squared plus 60 times 2 plus 25, so this gives me negative 5 times 4. Remember, you got to do squares before you multiply. 120 plus 25, so this is negative 20 plus 120 plus 25. Which would give me what? Well, I think I'm going to put these two together first. So that gives me 120 plus 5, which is 125. Okay, so now I know that that is 125, so we'll go over here. We said 400. We just solved for dt is 125. And then we just keep going. So plus 2b. Well, b represents, if a represents the distance up, b is going to represent the distance that I go to the right or to east. So we figured that out to be 300. So 2 times 300. And then how do I figure out dB dt? Well, dB dt at time 2 is in the chart, right? It's going to be 100. And this is going to equal to 2c, c being the distance, this distance here, which we calculated to be 500. And now we can solve for dc dt. Well, what is dc dt? Well, dc dt is the rate of the distance between. Okay, so that's what we were actually asked to find. Now we can solve for it. And so now all I gotta do is clean this up. So what's probably the best way of doing this? 2 times 125 is going to give me what? 250. 250 times 400, which is going to be what? That's just 25 times 4 is 100. And I have 1, 2, 3 zeros. 1, 2, 3 zeros. Over here I have, this is going to give me 600 times 100 is going to be plus 600, and then I just tack on 2 zeros. It gives me 60,000 is equal to 10 with 2 zeros behind it. dc dt. Okay, so we got that, and now all I got to do is clean this up, and we are good to go. So let's clean it up. So all of that becomes 160, comma 000 equals 1000 dc dt, and then I can just divide by 1,000. Divide by 1,000. So cancels. I'm left with 160 dc dt, and then let's go back to the beginning of the question. What is it asking for? It is saying find the rate. The rate is in meters per minute. Meters per minute. And there's my answer. Alright, so again, just to review, what did I do? I wasn't sure how to approach it. I drew a picture, right? Once you draw a picture, this is an indication that you are probably going to be doing a related rates question. We know that's 400, we know that's 300, we know that's 500 via the Pythagorean theorem. If I set it up via the Pythagorean theorem, then I know that I have a squared plus b squared equals c squared, so implicit differentiation gives me these values. From here, we just substitute in the values. A is the distance of A, which we saw to be 400. B is the distance of B, which is how much we went east, which is 300. And C is the distance between them, which is 500. From here, all I do is figure out what the dA dt is. dA dt is solved by plugging into this formula, which we did here. Okay. Then we calculate B. B at time 2 is via the chart, which we saw was here. Then we solve for dc dt. I ran out of space and did that over here. So we just solved the equation and we got 160. Something else that's common, by the way, is that a lot of people like to go through right here to solve it in a little bit easier way. If we divide each of these by 2, the 2's will cancel out. And then sometimes you can also go through and you can say, well, you can cancel a group of zeros out. So if the numbers were bothering you, that's a way to kind of make the numbers a little smaller. It really doesn't matter. If we look here, the numbers become small here as well. Okay? Hopefully that makes sense. See you all in the next video.